Are there questions about this one? So definitely not a pretty thing to check if you go plug it back in. But the strategy is still the same, right? If I start off with 1 over x plus 2, and I want to add what? 1 over x equals to 1. This is the new stuff for today, right? I want to do the LCD. So I'm looking at this thing. I know my LCD is x and an x plus 2. So I have to multiply everything by x and x plus 2. So this is the new stuff that I'm hoping gets taken away today. The other stuff wasn't the prettiest, right? But it's stuff we've covered. It should look at least somewhat familiar. If I multiply everything by the LCD, I should end up getting rid of some stuff. I should end up getting rid of my fraction. So I get something like x plus 2. And then everything from here on out, I feel like is kind of a review of the stuff that we've been doing, right? It's, can you do a quadratic? Questions about this one? I think the main thing where things are going to go wrong is that you're going to get a 0 in your denominator, right? So if we get something like plus or minus root 2 for a solution, just making sure that doesn't give you a 0 in the denominator is one of the main things you kind of need to look for. That's where things start going wrong with rational equations, or rational, yeah, equations. I said the right word. Okay, if there's no more questions, we still have what, 17 and 25. Those are going to take a minute. I feel like 17 might be a little quicker. 25, there's different ways to do them. They might be a little quicker, actually. Okay. If there's no questions, I'm going to open up breakout rooms again. Zoom. Okay. Okay, so if I plug this in, what is that? 49 over 25. Dividing by that, 35. 49 over 25. We can do the copy dot flip if you want. So this would be what, 35 times 25 over 49. So it is pretty messy. If I'm being honest, if I were to check my solutions and I were to have the option to use technology on this thing, I would definitely be plugging this into a calculator to check this number, or I'd probably be throwing it into Desmos. Like, I'm probably not going to do this in my head and like try to do these calculations by hand or anything. I'd probably throw it in the calculator and check it right quick. But you should know how to sort of do it, right? Even to throw it in the calculator, you have to know how to go plug it back in. And I want to check 7/5. And the other thing I want to do is I have another solution. I have to check both solutions. I also have to go plug in what, minus 5/3 back into this thing. What were my domain restrictions if I look at the original problem? What can my x not be?
0.
Because we have 1 over x squared and 1 over x, right? Both of those are giving us x cannot be 0. So as long as it's not 0, these probably should be valid solutions. Like throwing it back in and checking it definitely checks it for sure to make sure it matches up and it is the correct solution. But as long as you're not getting something that is 0, it shouldn't give you the 0 in the denominator, right? And give you the undefined stuff. Are there questions about this? I know their quadratic stuff is a little messy in this section from what it looks like. But the important thing, the thing that we're adding on, right, is the sort of, can you find the LCD? Can you multiply everything by the LCD? So if I have something like 4 over x squared minus 3x, and I have this is equal to 1 over x squared minus 9. I'm not called on. Leslie?
Yes. I didn't
How
get
might
to
you?
one, but I'll try.
Okay. So this one, if we wanted to, we could find the LCD. We could like probably factor this thing out. This is x minus 3. This is x minus 3x plus 3. We could find the LCD between these three things, which is, I believe, is x and an x minus 3 and an x plus 3. That's one way to do it.
Mm-hmm.
Although I personally probably wouldn't do it that way.
So
I don't know. Let me think. 3v6 and 2/4. If we want to know if these two things were equal, like going back to elementary school, do you remember how to check that?
are we gonna cross multiply or how?
Yeah, that's exactly what I'd do. I'd say is 12 equal to 12, right? Of course it is. So those two things are equal, right? So if we do that with this, what does that look like?
So we're just gonna cross multiply those, so it'd be 4 and then parentheses x squared minus 9.
Yep, so one side looks like 4 and an x squared minus 9. If you do the LCD, you'll find like you get to this next step. Like you're going to do some middle work, but you'll essentially get to this step that we're about to be at.
And then x squared minus 3x.
Yeah, and we're multiplying that by what? 1, so it just stays the same.
Yes.
And if we do that, now what do we have?
So then we would.
It's going to be what?
So we'll remove the x squared minus 3x to the other side.
Yeah, so you want to set one side equal to 0. I would do the distribution first, just so that we can like combine like terms and stuff.
Mm-hmm.
So I'd probably do the 4x squared minus the 36. It's equal to this thing, and I'm gonna have to delete some stuff, so I got some room up here to write.
Okay.
But yeah, that's exactly where I'd go. I'd subtract the x squared over. So we're subtracting. Oh, dang it! Go back to your pencil, Matt. Minus x squared, right?
Mm-hmm.
And so this gives me what? 3x squareds
Minus 36 plus 3x.
Yeah, so I would reorder it probably with the plus 3x, just so it's in descending order.
Minus 36.
Yep.
And then you would divide both sides by 3.
Yeah, so we can divide both sides by 3. That makes this x squared plus x, what, minus 12 is equal to 0 divided by 3 is still nothing.
And then.
Oh, this one should be able to factor it pretty easily, hopefully, right?
Yes, and then would it be x plus 4 and then minus 3?
Yeah, that's it. Finally, they give us one that's easy to factor. Those other ones were boogers, dude. So either what, x plus 4 is 0 or x minus 3 is 0. So x is a minus 4 or x is a what, positive 3. And I get that. I'm sorry, what?
Excuse me, the final results here, you mean we have minus 4 or what? What do you have? What do you have?
So I get these two results. X is a minus 4 and x is 3. What do I have to do now? I gotta go plug them back in and check them. So minus 4 squared, right? Minus 3 times what? Minus 4.
Yes.
Is equal to 1 over minus 4 squared minus 9. Is that right?
Teacher, something is missing there.
What am I missing?
Yes, because I don't know which steps. I don't know if me or you over there, but I think here we are going to have solution is just -4.
Yeah, so we're checking our solutions to see which ones will work.
Okay, go ahead.
Yeah, so it'll probably come up in a second what you're saying, I think. So this is 4/16, and we're adding 12, I think is what that is, and this is 1 over, we're doing 16 -9, right? Is what we're doing on the bottom here. So I think what we end up getting is like 4/28, which is 1/7, and then we get 1/7. I think we're getting these two to match. So I believe -4 works. So now that I know this works, I should probably do something like box it, right? This one definitely works. We checked it. What about the other one? What happens when I throw in a 3? Do y'all see it? Maybe. Maybe not. So now I'm throwing a 3 in there. What's going to happen?
It's not going to work because the only solution here is just -4. It's not the other one.
Okay, so what happens though?
It's like when you upload the -3 or the 3 there, it's not going to be to give us a 0.
Why doesn't it work? It's giving us a 0, right?
Yes,
In where?
in the other side. Because when I simplified my equation, I put everything on the side. I did the whole thing. I find I have just my equation as with one items with one. I'm sorry, with one terms.
Yeah. So it's correct. We're getting a 0, but we're getting a 0 in the denominator, right?
Yes.
When we throw this thing back in. So we cannot have this thing. This is not a solution. This is what they call an extraneous solution. It's something we thought was a solution, but when we go back and check it, it does not work for this equation.
But only teacher, when we are going to solve our equation, when we solve it like correctly to divide, to multiply the whole thing, in the end, we are going just to find 3x plus 12 equals to 0. What I found, I didn't find 2 results because I did the whole thing by steps. And then in the end, I found 3x plus 12 equals to 0, which is x equals to -4 directly because I did,
I think if you solve it differently, you might get.
I solve it differently. I get just one solution in the end.
That might be possible. Yeah. Did anybody else do that?
I did. I found like a LCD.
Yeah, if you multiply it by the LCD, I think you get around that.
I got one solution. It was only -4 that I got.
Yes, the only one is -4. We can't find 2 solution here because just with steps, put there, move the, I don't know how can I say it, but.
Okay. So we do this with the LCD. It looks like we're probably just going to get the one solution. That's possible. You might not get that extra one because I think when we didn't do the LCD, I think we end up multiplying by it, and that's probably why it gets thrown in there.
Which way should we be doing it?
Either way, you should check your solutions and make sure they work.
Okay. So like if you were to do it if you do like the LCD way, do you always get only one solution or sometimes you get 2?
I'm not sure about that, to be honest.
No, it depends which method you used to find your solution because there are many methods. Right, teacher? I don't know.
Yeah, so there's a few different methods you could use. So I think what y'all are doing is doing x times x plus 3 times x minus 3, right? And so everything, my x minus 3 and my x get canceled out here. And same thing over here, I do x plus 3, x minus 3. And I believe these two things get canceled out here. So I have something like 4 times.
4 times x minus
this x is gone.
Plus 3, yes.
4 times x plus 3.
X minus 3, but then you are going to
x,
cross.
right?
Yeah.
So what is this? Did I do this right? I didn't do distribution correctly, did I?
No, the 3 is, yeah.
That should be 12, right? And so we subtract it. I think we get a minus 3x is 12, and we'll get the x is a minus 4 this way.
Yep.
Yeah. So depending how you solve it, you may not get that extraneous solution.
Because in the end, you are going to have to use your, what did you said before, butterfly, and just to have your denominator as a 0, and then you solve it directly.
And if we factor things all the way, we can also talk about domain restrictions. So we get an x, so x cannot be 0, and x minus 3 cannot be 0, so x cannot be positive 3, and also x cannot be negative 3. So I think these are the 3 domain restrictions we're getting from the denominator.
Yep.
So if we get any one of those things and as a solution, we have to reject it, right? There's no way we can divide by 0. These are the things that make us divide by 0. These are the things we don't want.
Yeah.
Okay. So that 25, the next one, 111, that's, I don't know what to tell you besides look at it.
One.
What's up?
I think the 111 is a little bit complicated. I don't know.
Yeah, it's a
Maybe
little bit
I
complicated.
can't
Am
do
I sharing
it.
right screen? I hope I'm sharing right screen. All right, so 111 is this one. I want to talk about a little bit just before we get out there. So they're finding the braking distance of something, of a car on like a wet uphill grade or something. There's different things they can say, dry, downhill or something. We can change it around a little bit depending upon weather conditions or whatever the heck they want. But the grade x of a hill is measured of its steepness. So they say something like x equals 10 over 100. They're basically expressing it in decimal notation, right? So 10% grade would be 0.10. If a road rises 10 feet for every 100 feet that you're going horizontal distance, then it's a steepness of 10%. The braking distance for a car traveling at 50 miles per hour on a wet uphill grade is given by this. So this is the function we want to use. Evaluate D of 5.
Do you write the function teacher in the I don't know where you
So what is D of 0.05? What does that mean? Like, how am I going to solve that?
just to upload the point in the equation.
We put this into the equation. So am I substituting this into my x, or am I substituting this into my D of x? That's the question.
Into your x.
Yeah, this is an x variable. So this is going back to, do we know what a function is, right? Do we know whether we're doing it into the x variable or doing it to the y variable, the d, or aka d of x, right? And so if we do that, I hope this one takes you a few seconds. D of x, or I should say D of 0.05. .05, right, is when I plug in 0.05 into my function. So I'm going to do 2,500 on top. Let's figure it out right quick. 30, and I'm doing what, 0.3, what, plus 5, 0.05. I'm going to do this by typing stuff in. So 2,500 is on top. And I'm doing that over 30 times 0.35, I believe, right? So I'm getting something like 238.095, 2381, somewhere around that ballpark. I don't know, let's go 3 decimal places. 238.095. Okay, so what does this mean? We have the results, but now we have to be able to interpret them. These two numbers were over themselves, and we got this. How do I interpret that? And remember, this function compares what braking distance to the slope of the road, or to the, what do they call it here? Steepness, the grade, I guess is the word they're using. Talk about grades when you do roads. You talk about pitch when you do roofs. It's all the same thing. They're talking about the slope of the thing. Someone help me interpret this. What does this mean?
Maybe how many miles, or I don't know, because I can't
The
read.
unit is feet here. Oh, whoa, that's weird. Yeah, it's kind of weird because they give you the speeds of the car in miles. But yeah, it should be feet. So what are my feet? How many feet is it going to take me to stop?
The number you find in the results.
Yeah, so that 238.095 feet,
Yes.
it'll
Feet.
take, that means, yeah, it will take, so probably something like it will take, right? This many feet to stop. When? So when is it going to take 238 feet to stop? This should be a review, man. Like, I don't know why.
Maybe we need to multiply by the number of the distance.
So you gave me the y. I also need to know something about the x. This y occurs when x is what?
Okay, m of x plus b. Yeah, I think now we need to find the. It's like the equation for the linear function, and we have our rate. We have y, and now we need to find the b. Right?
What was my x that I plugged in?
0.
No, 0.05, right?
Okay, 0.5. Yes, because sorry.
So what does that mean?
It's the rate. The change of rate. This is the slope.
Yeah, it's the slope or the grade, right? So what does that
Yes.
mean when I have a 5% grade? And they say like maybe on wet uphill. We could be a little more specific, maybe even, right? On wet uphill. Road. Questions about this? That part should be like pretty much kind of a review. Like I put in an X, I put in a Y, I find my correlating Y for that X value, and then I interpret the results. I say when the Y is whatever units, or it'll take the Y to be at whatever units when my X is whatever the heck it's measuring, right?
Then
So it'll take 238 feet to stop when you have a 5% grade on wet uphill roads.
like we need to say the how we found for the y and then the slope, right? When the slope equals to something, right?
Well, there's not really a slope here. Slopes would be on like linear equations, right? We're doing rational expressions. What we need,
Yes.
we need the y variable and we need the x variable that you put in. And to tell me what that is.
I'm saying about how we can interpret the results. This one is sometimes they have this.
So when you interpret the results, you're going to tell me the y value and you're going to tell me the correlating x value. So 238 feet for 5% grade, right?
Mhm.
So what does that mean if I like throw in some more English? It's going to take me 238 feet to stop when I have a 5% grade. Okay.
Thank you.
And just want to think about this. And I know they said don't do B, but we're going to do B. Describe what happens to the braking distance as the hill becomes steeper. So what's a good way to do this? If I'm being lazy, what am I going to do?
Everything equals to 0.
I'm going to throw it into my Desmos. Is what I'm going to do.
Ah.
So if I want to see what this happens, I put this in my Desmos. This is the picture it gives me. So what's happening? I don't see anything. Why don't I see anything?
Because you don't have any x and y's.
Yeah, they're there. This is my equation. So why don't I see anything on here when I first plug this in? I'm just making sure y'all are awake. What are y'all doing? Oh man. What might be wrong with this? I'm going from -10 to -10. So what would you do if you did this? I'm trying to see what your approach is to understand stuff. Do you do you understand how this is modeling it? That's what I was trying to get at within these next couple pictures. So why don't I see anything? If you do a graph and you don't see anything, what should you check? It's like the first thing you should check.
Your x-intercept, y-intercept. So
Yeah, like maybe looking at where it intercepts with the y and the x. I don't think you're actually going to find any intercepts on this thing.
yes, because
It's actually got asymptotes, and you're not going to find intersections probably. Is it like, are y'all like, is this a weird question? Or is everyone just asleep? Like, what's the deal? Like, I'm trying to walk through this so you have like a better understanding of how things are modeled. And it's just like silence. Kind of worried.
I'm just so confused. I'm just trying to understand it.
Okay, well, like if you graph something, right? And you don't see the graph, what are you going to do? Zoom out. That's what I was hoping someone would say. Like you just zoom out on the graph, right? You're not in the right window. You got to adjust your window somehow. So I have this window. It's a little bit better adjusted. Oh, I don't need this anymore. I think I went from 0 to 300 in my Y. I'm going from 0 to 10 in my X. Is this what you would think when you're going uphill and you're stopping? Does this make sense?
Yeah, it does.
As the grade increases, right, what happens to your stopping distance? As I increase my grade in my X direction, what direction is my stopping distance going in?
asymptote. Yeah, now yes, to the your
It should be going down, right?
Yeah.
Maybe we got an intercept there, 0.277. I guess there's intercept. Yeah, so hopefully this makes sense, right? We start out going with a very, very shallow sort of steepness. If it's not very steep, it's going to take you a long ways to stop, right? As we start going more and more steep, it's going to take us less time to stop, less distance to stop. Okay. Estimate the grade associated with the braking distance of 220. So what are they giving me here? How do I set this thing up?
x equals to 220.
What is my X measure?
Feet.
D of X measures feet.
Miles. No, it's miles. No, I don't know.
X measures my steepness or my grade, right?
So
if they tell me 220 feet, what are they giving me?
The distance, the
Distance.
braking.
So if I set this up, what should it look like? Where am I plugging this into?
it's like your
To the
y.
D.
Yeah, to the D of X or the Y. So I'd plug this into my D of X. So doing that, this should look like what?
Equals to the equation. The number equals to the equation.
Yep,
Okay.
exactly, right? I'm setting this number equal to this equation. I'm solving just like I've solved everything else in this section, right?
Yeah. So,
I have an extra 0 here, should be 30. Sorry. So I'm probably going to distribute stuff, do that. So I think I'm going to give you all some time to try to solve this. And there are, I believe, 2 more problems after this. We're doing what, 119, 111, 119, 121, and 125 and 126. So I think I'm going to do breakout rooms for just a few minutes. Whoop, not the thing I wanted to pause. Here is my recordings up here.